Hello, so in this video we'll talk about the Fibonacci numbers. Basically what we want to do is we want to prove or check two properties of Fibonacci numbers. Okay, so before we talk about those properties, let's have a review of how do we define those numbers. So they are defined recursively, that the first two are 1 and 1 and the next um, number is actually the sum of the previous two numbers. So if we make a list of it, we can see 1 1, then these two will be summed to 2, then the next last two will be summed to 3, then 5, then 8, then these two sum to 13, then these two sum to 21, 34, and so on. Okay, so we are interested in finding the limit of k plus 1th, k plus first Fibonacci number uh, to the kth Fibonacci number, so limit of that ratio. Okay, and then we want to prove that the GCD of the every adjacent number is 1 for all values of k, and you can check it from here as well. The GCD of these two numbers is 1, GCD of these two numbers is 1, and so on, but we want to prove it in a general sense. Okay, so let's now prove the first one. So we'll say limit k tends to infinity f k plus 1 over f of k. So by definition, what is this guy? The numerator, we can say this is f of k plus f of k minus 1 over fk. And then again, limit k tends to infinity. So I can say this is limit k tends to infinity 1 plus f of k minus 1 over f of k. Correct? So then I can take this one out. So 1 plus limit k tends to infinity f of k minus 1 over f of k. So let me call this guy as L. Okay, so then I will say this L is equal to limit k tends to infinity f of k minus 1 over f of k. So I can write f of k in terms of f of k minus 1. So I can say limit k tends to infinity f of k minus 1 over f of k minus 1 plus f of k minus 2. Remember that this guy is the sum of the previous two guys. So then let's divide this whole thing by f of k minus 1, the numerator and the denominator. So I can say limit k tends to infinity 1 over 1 plus f of k minus 2 over f of k minus 1. So I can say here is equal to 1 over 1 plus limit k tends to infinity f of k minus 2 over f of k minus 1. So now it's easy to see that this guy is also equal to L, because this L and this L are the same. What we are saying is taking the ratio of the one term to the next one when k goes to infinity. So minus 1 and minus 2, they don't change the the limit to limit at all. So then I can say L is equal to 1 over 1 plus L. So then I can say L squared plus L minus 1 is equal to 0. Okay. So now here I can use the quadratic formula here. So I can say L, this is equal to minus 1 plus or minus 1 squared plus 4 over 2 times 1. Correct? So then I can say minus 1 plus root 5 over 2, or minus 1 minus root 5 over 2. Now note that this is not the right answer, or we can discard this because Fibonacci numbers are always positive numbers, right? So their ratio cannot be a negative number. Okay, so then this is my L, but my limit of this guy is actually 1 plus L from here. So I can say limit k tends to infinity f of k plus 1 over f of k this is equal to 1 plus minus 1 plus 5 root 5 over 2, which is equal to 1 plus root 5 over 2. So this is actually the golden ratio. So that's pretty cool that these 5 Fibonacci numbers, when you have enough of them, the ratio between them is actually this number. Okay, so this is the first part. Now we are interested in part 2, which is the GCD of f of k and f of k plus 1. Okay, so first of all, what we want to do is we want to find how do we find GCD of any two numbers. Okay, so let's say I have numbers 28 and 40. Okay, how will I do the GCD of these two things, these two numbers? I will say 28 and 40 here. So 28 goes into 40 one time, so 28, then 12. Then I have 28 inside, then 2 times, then 24, then I have 4 here remainder. Then 12 goes inside, then 3 times, then 12 here, then it goes. So this is my GCD of these two numbers. So in other words, GCD of 28 and 40 is 4. Okay, is the first thing. Now we will use exactly the same approach to find the GCD of f of k plus 1 and f of k. So f of k is obviously the smaller one, so f of k plus 1. How much time does it go into f of k? It goes 1 time, and I'll say f of k. So if I subtract these two, what will I get? I'll get f of k minus 1. Why? So why? Because let me write it here. Because f of k plus 1, this is equal to f of k plus f of k minus 1. Correct? So then if I subtract these two, I will get this guy. Then I have this guy here. And also it's 1 time. Then I will say f of k minus 1. And then I have f of k minus 2. And then f of k minus 1 here. And then f of k 1 here. F of k minus 2 here. And f of k minus 3. So now you can appreciate that this procedure goes on and on. So I have inside is f of k minus 2. It goes on and on until I reach 1, let's say I reach 2 here and 3 here. So 1, 2 and 1 and 2. Then I say 2 here, and I say 2 here. So this is my GCD of these two numbers. Okay. Now the only thing which is remaining to be proven is why do we have a quotient of 1 here? Okay, we have a quotient of 1 here because that if we have f of k plus 1 divided by f of k, I can write it as f of k plus f of k minus 1 over f of k, which is equal to 1 plus f of k minus 1 over f of k. Now this guy is strictly less than 1 because we have an increasing sequence of numbers. So this is my coefficient here. So that's why we have 1 here all the time. And in the end, when we are left with this 1 and 2, only then we can have 0 remainder here. Okay. So otherwise we always have a remainder. So this is my 1 here. So this means what we have done is we have proved that GCD of any two adjacent numbers in the Fibonacci series, this is equal to 1. Okay. So this is two small properties of Fibonacci numbers. So hope it was easy to understand, and thanks for watching. Hope you liked the video.